I would have procrastinated it anyway, so it's not going to affect the quality of the talk. Yeah, so I'm doing this human factor research. This picture is from Saddle Peak, right outside of the Bridger Bowl boundary. And this was taken just a couple weeks ago. It was a really interesting day. We were up there. I think I was up there for 35 minutes. And I handed out, so my research, I hand out GPS units. I handed out 10 units in 35 minutes, which is all I have. And at the same time, I was looking out the ridge and watching natural wet avalanches come down, but it was just a train of people because the whole rest of the Bridger train was closed. So the whole ridge train was closed. The only thing open was Saddle, so everyone was heading here. So it was a really interesting day for looking at human factors. Yeah, as Doug said, I'm a master's student with Yordi Hendricks at Montana State. My background, I have a psychology degree from Alaska Pacific University, and then I've worked as an avalanche educator and kind of mountaineering guide for a long time since then, or 5 years or so since then. And this on the bottom are some of the, not necessarily financial sponsors of the research, but more moral support. So MSU, Bridger Bowl, the Friends Group, and the Friends of the Highlight. Wrong way. So the research questions that we're looking at are, the first thing we're looking at with these GPS units is how people are using the terrain on different days. So we're trying to use the avalanche forecast and the weather conditions and kind of see how people's terrain use changes throughout different days. Yeah.
If you stand next to the podium, the sound is going to catch you for the recording.
Oh, got it. Really limiting me here, Doug.
I know.
So also in addition to the GPS stuff, we're handing out these decision-making surveys. So it's like a 20-question survey trying to figure out what's driving some of people's decisions. And then the final thing that we're doing is we have kind of a sample design going where some days we put out a backcountry avalanche sign and inform people of the hazard. So whether they've read it or not that morning, we're just putting out the public forecast. And so we want to see if that's actually affecting decision making. So does it make a difference if ski resorts and national forests are putting out that information, or are people kind of traveling the same under all conditions? So this is the field site. Most of you guys are probably familiar with it, but this red line is kind of the boundary line. And a bunch of these slides I borrowed from Diana Sally, who was supposed to give this talk. So this is kind of her part of it. We see a lot of use generally in this football field area, which is just adjacent to the boundary. And there's a marked bamboo with ski area boundary signs, but there's no physical rope line there, so you can just travel right through it. And then other than that, most people either are going to ski somewhere close here in the football field, or they'll head up the whole peak and ski from somewhere from the top of Saddle Peak. And almost all the use is on this east face of Saddle because there tends to be no snow on the west face. Okay, so why we care about this? This is just a photo of a big a human-triggered avalanche, I believe by a cornice coming down off the Saddle Peak that was triggered with multiple people on the slope when this avalanche was triggered. And there's a lot of good YouTube coverage of this if you just Google it. There's a video with Carl and Doug up there, and there's also a video of people shooting the powder cloud going by them as they're in the backcountry on Saddle Peak. So this is kind of the reason we're interested in this area is it sees a lot of use, and it seems like it sees use under all kinds of avalanche conditions, not necessarily when it's just appropriate to be used in this terrain. Here's another avalanche event on Saddle Peak. This is more in that football field area, so kind of on the far right of the backcountry terrain. And you can see the reason why these avalanches are really significant. That first one obviously was really large, but these cliffs down here are like up to 200 feet tall. So the consequences of any size avalanche that's going to take you over that cliff is really high. And this crown was like a maximum of 4 feet deep and about 200 to 300 feet wide. And this debris ran all the way down underneath the cliffs. And then the last avalanche event, this is from Diana, another person who works in the snow lab with Chris Bilbrey and myself. She has a time-lapse camera set up on Saddle Peak, so we're kind of looking at it from a couple different angles. And this is from her time-lapse work last winter. These dots over here are people that she's tracking. So it takes a photo like every 5 or 10 seconds, and she just tracks the movement of people through that. And she, in her camera, she saw these people trigger the avalanche, which you can see now is running over that lower cliff band. So really high consequence terrain, despite the fact that it's like one ski turn from being in fully avalanche controlled area at Bridger Bowl. So that avalanche was about 1 to 2 feet deep. Not a huge avalanche, but really high consequence because those cliffs are there. Okay, so what we do for our field research, I should preface this by saying this has been my first year of data collection, so I don't actually really have any results yet. All I have is kind of some pictures of tracks and kind of field methods, so don't get too excited about results. So what we do in the morning, we wake up, we have this avalanche board already set up, and so we just flip a coin if we're gonna put out the forecast or not. Days where we don't put out the forecast, I just kind of hide it in the rocks off the side of Saddle, and then days where we do, I'll show a picture of this, but we just print out basically the whole Gallatin public forecast. And then we stand up at the ridge right at the boundary, so we know our participants are in the backcountry, and we hand out GPS units. It's all voluntary, and most people are pretty excited about the research. They have questions about it and are interested. And there's some grumpy old timers that are not as interested, that just want me to not talk to them, which is fine too. And then we collect the units at the base of Slushmans. So this terrain is really great for our research because everyone pretty much comes back to the base of Slushmans. So we just hand them out at the ridge, collect them back at the base, and then we hand out that survey. I'm not really going to go into the survey here because I haven't even entered that data into the computer yet, so there's nothing exciting there. And then in addition to collecting this field data, we make field obs on the weather conditions, the snowpack, if we're seeing any signs on Saddle, and then also the ski quality and the ski conditions. Because I'm going to just take a preliminary guess that ski conditions are driving people's decisions up there more than anything else, just from being up there this winter. So this is our little avalanche board. We change this forecast every day, and that just reflects whatever the highest level of avalanche hazard is from the day. So this, I believe this day has both a low and a considerable forecast, so we just take the more conservative of those and put them up. And then we post the forecast there. And this is just outside. If you guys have been up there, there's a big Forest Service sign, the yellow sign that says you're leaving the backcountry, and this is just like 5 feet behind there, kind of right next to the trail on Saddle. The GPSs we're using are these handheld kind of recreational grade Garmin GPSs. These orange ones on the top, this is from research by Jordy Hendricks, but they're supposed to have an accuracy of about 5 meters, and then they log a point every about 2.5 seconds. So we end up with just a whole bunch of points for where these people are traveling in the backcountry. And one of the things I'm going to try and use to validate that is this higher accuracy GPS. And so these are way too expensive to just be handing out to random people. But what we do is take them and then put them both, turn them on, put them in our pack, and then ski with both of them and compare the accuracy between the two. So these yellow ones are accurate to like about 10 centimeters. So quite a bit more. Another piece of data that we're collecting up there is this trail count data, and this was loaned to us from Friends of the Highlight. And so it's an infrared counter, so it just counts if something warm goes by, which luckily on Saddle there's really nothing warm other than skiers up there. So it's counting in theory everyone that walks by. And this is kind of our goal here, is to look at how many people we're capturing, both with the time-lapse camera and the GPS units, compared to the total population that's using the terrain up there. And then
counter going every day?
It's supposed to go for the whole winter. That was how Joe sold it to me, but we've had some issues. Next year, hopefully, it'll go for the whole winter. It tends to heat up in the sun and then just count constantly for the whole hour. So you end up with like 1,000. You're like, I don't think, it doesn't seem right.
So it's undercounting the people.
Yeah. So part of the analysis, mostly that I'm going to talk about here, is just taking these GPS tracks and then putting them into GIS software and trying to get a sense for the terrain people are using. And so we're just using publicly available data for this. We're using a digital elevation model. that we can then use to kind of create these other parameters that we're interested for terrain. So we're looking at angle, aspect, and slope curvature to try and give us a sense for what kind of terrain people are using. So this is just a picture of our standard GPS track. So this is what I get back after a day in the field. Again, the red is the Bridger boundary and this black is the Slushman's lift. And so this is Google Earth, and so it just takes all the points and puts them into one continuous line. So I have 3 tracks here from 3 separate users, and you can see some little parts of the track are actually inbound terrain. So part of what I do is I go in and I cut out all the inbound terrain, and then I need to split this into 3 tracks and come up with a way to link it to the survey data. So we have this kind of more complete data set. And then on the bottom here, it's just showing elevation and speed of travel, just calculated from those GPS points. This is kind of part of that merging of the human factor data with the spatial data that we have from GPSs. So we're starting with the raw GPS file, and then we're doing some conversions so we can add in all of these terrain values to it. And I'll show you kind of what these look like on a map in just a second. But yeah, we're adding in all these terrain values. So for each point that somebody travels through, and we get an average between like 50 to 200 points per track, then we can look at exactly what the slope angle aspect for each point along the track is. And then in the end, we're going to have this survey data combination with the Avalanche Forecast data, as well as my field observations, and then weather data from the Bridger Bowl kind of weather system there. And so this is just a Google Earth shot of Saddle Peak. And then this is kind of what our slope data looks like. So you can see here, there's no coloring for stuff below 25 degrees, and then the darker red you get into, the steeper terrain is. So as the point travels through here, it just kind of pulls whatever value it's overlaying on the map and adds it onto the GPS file. So that's our slope angle. This is our aspect. So these red colors, red to kind of purple, are north facing, and then getting into the more green and yellow is more south facing terrain. This is our land cover, so we want to look at if people are traveling in like heavily treed terrain or if it's mostly open, more alpine terrain. And then this one looks very, well, same colors as the aspect, but what it's actually showing is the slope curvature. So it kind of tells us the red, kind of hotter colors are convex rollovers in downslope direction, so kind of likely areas that you might trigger a small avalanche, and then the green colors are more concave sections of the terrain. So we're not exactly sure how we're going to use these, but we kind of base these on the AITS model that they use up in Canada, the Avalanche Terrain Evaluation Scale, and some of the same variables that they use to classify avalanche terrain we just pulled out and added to these GPS tracks. So what we've got so far, we've got like around 140 tracks so far from this year, and I haven't had a chance to process all of them, but the overwhelming majority is from moderate avalanche danger, which is just kind of function of the season. We haven't really had, initially I was hoping we'd have more persistent conditions, so I could compare kind of like persistent avalanche problem versus non-persistent avalanche problem and see how the travel behavior changes, but I didn't get a single day of persistent avalanche conditions this year. So that'll be a goal for next year. And then we have 2 days of considerable avalanche hazard. And then by avalanche problem, we have mostly wind slabs and wet avalanche problems for our field days, which is kind of, yeah, been just the nature of Saddle Peak this year. This is all that data in a little more detail, and I'm pulling all this data off of just the public forecast, so that same piece of paper that I slip in the avalanche board, so that it's kind of exactly the same information that the public has to make decisions on without going to any additional, like looking at weather stations or anything like that. So it should be, if they're reading the forecast, all this information comes right from there. So primary things that I'm looking at in these maps are the hazard for the day, and then this column is the previous day's hazard, so we can kind of see how the avalanche conditions are trending. And then also the primary avalanche problem for the day is what I'm going to show in the maps of these different tracks. So these are all of our tracks that we have from a moderate forecast day. You can see it's widespread use all over the place. Some of these, and this is using a technique where we just take the most conservative avalanche hazard. So some of these days were wet avalanche conditions where we kind of start the day with a low avalanche hazard and then we progress into a moderate or considerable hazard throughout the day. So eventually I want to go back through and pull out, based on the timing, pull some of those tracks that probably were put on the terrain in low hazards and put them into a different group, but haven't had time to do that yet. So this is our moderate, and then these are our considerable tracks. So obviously we have quite a bit less considerable tracks, but I think it's pretty interesting. You see a real concentration of tracks here on this kind of central ridge, and this is kind of the skyline that you're looking at. If you're in the Bridger Bowl area riding up the chairlift, that's the skyline, which has pretty high trees. It's definitely one of the safer routes down. It's far enough south that it's not really exposed to these cliffs anymore. And then the other one that I think is really interesting is we still get a lot of use in the football field. And that I think is one of the, from a human factor standpoint, that's a really interesting piece of terrain just because of how easy it is to access. You're not hiking any further to ski that terrain than you would just to ski the boundary line of Bridger. So yeah, I think it makes for a real difficult decision if you look over there and it's untracked and seems like a lot better skiing versus skiing the kind of crud inbounds. So these are those same tracks just with the kind of slope angles underneath them. So here we have moderate tracks, kind of people, there's a little outlier out here, but generally people not being too shy about going into some of the steeper pockets of terrain. And then again, here we have considerable tracks. So a lot of people sticking to this lower angle ridge, but then we see this upper football field area where a couple of those avalanches that I showed in the beginning of the talk were triggered is a steep area, but we still have quite a bit of traffic there. And then I also broke it down. So these are wind slab problems. So these are the days where the primary avalanche problem was wind. And so again, we see a really high concentration of use on the ridge here. Keep blocking my own laser. And I'm definitely not an expert on the saddle terrain because I've only been here for 1 year. But yeah, interesting that most people are kind of starting from that one point right at the summit. And then versus a wet avalanche problem where we see a little bit more people kind of spreading out over across the saddle terrain. So a little bit more widespread use. And then the last things I have here are with the aspect. So this is wind avalanche problem with the slope aspect underneath. So we can see even though the wind loading typically on saddle comes out of the west and kind of loads the ridge, we still see mostly kind of north facing aspects being used. And then with the wet avalanche problem, we kind of actually see a similar trend. So a lot more use in the red to orange spectrum of this map than any others. So kind of somewhat maybe conditions dependent there with the wet avalanches. So where we're going to go from here, we're going to try and do a little bit more analysis on kind of picking apart the avalanche conditions a little more, like I was saying, by time of day, and then also adding in the survey data in there. So we could say where are most experienced users going for a given type of avalanche conditions, or where are more inexperienced users going. And then I also want to try and use a GIS model, which I'm not sure if it's going to work, but to come up with a way to kind of pick a starting point. So say we have a ski track that goes somewhere that we think is particularly interesting, and pick that starting point and then have a computer model tell us what the safest line down would be from that starting point, so that we can then compare the computer model track to the actual GPS track and try and come up with some ideas about why people are making those decisions to go into higher risk terrain. So yeah, that's pretty much all I got. Yeah, thanks to Yordi, Hendricks, Jerry Johnson, and Carl, my committee members, and then everyone who's been helping me in the field and with kind of logistics and analysis. Does anyone have any questions?
Make sure you wear the fluorescent vests.
We started doing that so we could set ourselves apart, but we realized that just by bugging people every time they go up there, they figured out who we are. So yeah, we don't do that anymore. That was an early season idea. But Diana looks really good in here. I had to put her in there. So this was her talk anyway. Yeah. Yeah.
Do you think actually being there, handing out GPS units, that communication between you and the user would change their use at all?
I think it definitely does for some people. Like some people who would probably just blaze on by without thinking about it or communicating to their group about it. If we're there, ask him like, why are you going there? Like, do you want to carry a GPS? And they're like, oh, but should I go over there? Maybe this is sketchy. So I think some people do. Some people just kind of take it and keep going. There's a lot of solo skiers up there too, so there's not a lot of group discussion to be had. But yeah.
Do you have any people have a concern about interference with the GPS in the region?
No, I haven't had that concern. That's a good question though. I hadn't even thought of that.
Don't worry about it.
Yeah.
We're skiing solo.
Might even have a pack. The beauty just got on the left.
John, can you switch back to one of the sloping
Yes.
slides?
Any particular one or?
Yeah, it's a little surprising if you look at the main ridge where, a lot of the traffic goes down, but you look at the looker's right of the ridge, and that's kind of the zone where the big slide occurred.
Yep.
But it's green, and it's,
Yeah.
you kind of, it might be deceiving, I don't know, but it seems steeper than 0 to 25 in a lot of those in the main face there of the north of the ridge.
Yeah, that's a good point. I
Just
don't.
all the green kind of in the center of the saddle there.
So
To me, it seems steeper than that, but
this is
maybe
based
that's actually the safest place to go.
right down there. This is based on that USGS DEM, so it's got a 10-meter size sail, and so what it's calculating is like each sail is 10 meters, so it kind of misses some of the nuanced terrain. It averages a lot of that out. So I think it highlights some of the big steep areas, but it might miss some smaller terrain features. But I could also, but yeah, that's
And typically you're averaging it over 3 cells, I think, so. aren't
Yeah.
you? So you got like a 30 meter.
I think it's average. Yeah, well, I think it uses a whole neighborhood, so it's like so it's 8 cells technically. I don't know enough. You might be right that it's kind of 3 stacked on top.
But so you end up with a pretty long distance.
Yeah.
That you're trying to get that slope angle at.
Absolutely. Yeah, and so one of the things like Chris was talking about in his presentation, LiDAR and structure for motion, and those are things that will give us higher resolution. So like 1 meter or 5 meter resolution, so you could have a little more confidence that you're capturing the terrain, the subtle terrain changes. But those things LiDAR doesn't exist for this area, and structure for motion is a whole headache on its own. So this is kind of the best that we have for now.
It is really, I don't know, it's pretty encouraging actually when you look at the moderate tracks and the considerable tracks, the kind of the difference between not only their numbers but the terrain selection.
Yep.
So it's, I don't know, it's pretty encouraging, really.
Good. Yeah. Yeah, I think we didn't really nail it on hitting a day. I think the ideal day to see considerable behavior out there would be right after a big storm, like that huge load we had. If I would have been out there on that Monday where it had just dropped to considerable and then they opened the boundaries, I think that would have been maybe a different story, but it's hard to say. So next season we're going to try and, I have enough data now that we don't need to go out like every weekend. We're just going to try and pick these specific days and try and fill in the gaps a little bit there. Yeah, but that's a good point. Any other questions?
Bigger study going on, getting GPS tracks not just from like here, and is that going to be part of your study, or wasn't Jordan?
Yeah, Yordi is doing the ski tracks project, so those are all backcountry tracks. And originally I was going to use just that data, but then I told Yordi that I wanted to go outside for my master's, so I went here. And here we also have more like constraint on the influences because we have avalanche obs, we have like the trail counter, so we have a little bit more idea of what some of the variables that are driving the terrain use. Whereas with the ski tracks, it's like you could be skiing in the middle of nowhere in Alaska with no avalanche forecast, no weather data, and you just send in this track that doesn't necessarily have as much information along with it. So that data set needs just a little more filtering and work, I think. But the idea originally is to compare the side country use with the backcountry use and see if there's a difference there.
Do you have any concerns of liability, like on a considerable day when you're handing out these GPSs, that if that person gets caught in a slide and dies, should you have been educating people as you hand these out?
Well, Carl and Doug, that was the first thing they mentioned when I proposed this idea. Yeah. And so, yeah, I definitely am concerned being up, especially if you know somebody doesn't have experience and you see them skiing down the football field right over the cliff. It's like, even if they take a GPS or not, I don't really want to be there at that time. Yeah, I guess in terms of like if people want to chat about the avalanche conditions, I don't like hold back any information at all, and I'll talk to them about it, point them to the sign, talk about if I've read the forecast or if there's any like, oh, I see some avalanches here, but I don't feel comfortable like telling people what decisions to make for sure. But yeah, Zach.
Did you look into, I know like smartphones, they track now where you move around. Have you looked into that at all?
Yeah, so the reason, that's what Yorty's other research uses, is a smartphone app. And the reason we're not doing that here is because we just want to have this quick interaction with people, and we don't want to have to convince them to like download an app up on the ridge there. So, but that is where most of Yorty's data comes from, is from coming more crowdsource. This one we're just kind of trying to be a little more invasive with it, I guess, and physically hand out the GPSs. And I don't know what, I'm also interested in the accuracy of the smartphone GPSs. And I think it'd be interesting to look at smartphone versus the Garmin versus the higher end one and actually see what kind of resolution you get from those. Cool. All right.
Thanks a lot.
Yeah.